today is understand first how to create the proper mesh in order to prepare the fibers path or fibers domain. Okay, so the process is going to be split into three parts. The first part is we are going to create the mesh object properly with some particular techniques. Then we are going to prepare the structure that will lie underneath the fiber system. And then finally, we are going to create the fibers, okay? We are going to do this at first without any structural behavior, okay? And then in the end, we are going to also give some structural performance behavior to these fibers, okay? So the process is going to be a topologically correct mesh object, and then preparing the structure for the fiber system, and then creating the fiber system. Okay, we are going to focus today on the mesh object in order to avoid problem in the next phases. Probably, as I was saying to Sagar, probably you already know something about mesh modeling, but I want to go through a very quick introduction. You know that mesh objects are a set of vertices connected by edges, and when you have a closed loop of edges, you define a polygon, okay, or the so-called face. When you have a mesh object, you can have several types of situation. The easiest one is having like three vertices like this, and then having some triangular face. Then there is the quad faces with four vertices, of course. And then there are the so-called anagons. The anagons, and means whatever number of vertices you might want to consider, and gons is from the Greek, which means basically angles. Okay, so from pentagons up, everything is anagons. Okay, now normally you might have read or heard somehow that it's best to work with quads. Actually, this is not absolutely true. It's true if you want to, let's say, create animation, of course, of your objects, like, I don't know, a 3D character modeling, for example. Then in that case, you don't want to use neither triangles nor anagons. Okay, you just concentrate on quads. But for us, it's probably it's irrelevant. For example, if you want to do a high resolution rendering with a very let's say high detailed model, then you can easily use triangles. Okay, there is no problem with that. We are going to work with quads in our workflow, not because we are going to animate our objects, but because we need this kind of topology. The particular thing about quad topology is that it has two orientations, right? So you can see that when you have a quad, you can flow through this quad horizontally and vertically, okay? Now, this is the reason why we are going to concentrate on quads, and we are going to also look at how we want to implement the mesh based on these quads, okay? Because not everything is horizontal vertical in our 3D models. So we are going to explain how to bend this kind of mesh topology to our needs. Okay, but we will be avoiding triangles and we'll be avoiding anagons. Okay, so we will focus on quads. Now, what I want you to understand, and this was the first step in the course schedule, the course program, is the topology orientations. Surely you work with Rhino. Okay, so you know that if you have a surface, for example, if I draw a rectangular surface like this, you know that this surface has at the same time some geometric properties and also some parametric properties. Rhino surfaces are mathematical objects, so it's like if this was a 3D graph of a complex mathematical equation, okay? And if you remember how mathematical equations work, then you should also recall that when you have some kind of graphic like this, then you have an independent variable, which is the x, with its variables like x start, x end. And to each value of this, you will have a y start or y end corresponding to it. So each value that you give to the x, you will have the correspondent value for the y, okay, like this. But there was also another representation, I don't know if you remember this from your studies, which is called the parametric representation of this equation, okay? And the parametric representation means that you can define x like x of another parameter, and then you will have that if y depends on x, it means that y also depend on the same parameter, okay? Normally, in terms of curves, this is like t because it resembles time. So time zero, you are here. As time goes by, you will have this graph being generated by the equations, okay? So these are the parametric equation of this surface. Um, we don't care actually about the equations. We just have to understand that this happens in our surfaces, which are a two-dimensional domain because it is made up of two dimensions. It's this one and this one. A surface is made up of an internal parametric coordinate system, which is called normally UV. I think you have seen this, the UV, at least when creating or when doing rendering. So for example, you have heard, of course, of UV mapping, for example. UV mapping means taking a texture, actually, and mapping that texture on the surface according to this UV coordinate system, parametric coordinate system. So each object has its own parametric coordinate system, internal parametric coordinate system. Now, we don't even care about coordinates. We only care about the two parametric direction, which are u and v, okay? Because these applies not only to surfaces, like NURBS surfaces, like in this case, but also to meshes, okay? So even if you talk about meshes, you will have a UV orientation along the mesh. And this is extremely simple to double check. If I take this surface, for example, from Rhino and bring it inside Grasshopper with this surface component, I right click, set one surface, select this, and I have it here, as you can see. And if I mesh surface this object, you see that the conversion from surface to mesh is based on the U count and V count. So U count is the amount of polygons along the U direction, and V count is the amount of polygons in the V direction. So if I, for example, use a slider 11 for U count and a slider 11 for the V count, you see that I have control over the amount of polygons in the U direction and the amount of polygons in the V direction, okay? Now, there is also one note about this. U doesn't mean horizontal, and V doesn't mean vertical. Okay, so U and V depends on the orientation of the object that you are creating. Okay, so for example, in this case, the U count affects the horizontal amount of polygons. But if I take this surface and rotate it like this, okay, as its topology is oriented like is rotated 90 degrees, the U is actually affecting the vertical amount of polygons. Okay, so everything depends on the orientation of the object. So what we must do is learn how to create a mesh object with the proper orientation and the proper UV topology. Why don't we do everything in Rhino Grasshopper? Because Rhino cannot handle complex mesh topology, not directly. Okay, uh, the the more complex results that you can create in Rhino are actually achieved by using Grasshopper, because Rhino mesh modeling tools are really like almost non-existent. If you go inside the mesh tool, for example, you see that there are some mesh creation commands here on the left and some mesh editing tools here at the top. Okay, but the only news that came up with Rhino 6 was the possibility to work with anagons. That's it. There is no other major feature. We are all waiting for Rhino 7 to come up because it will have some useful mesh tools like quad remesh and sub D and so on. Okay, but As for now, Rhino is absolutely useless as a mesh modeler. And then comes Grasshopper. Grasshopper has several plugins. Grasshopper by itself, it already has a mesh toolbar. Eventually, you will see that in my mesh toolbar, there are some additional comments, like there is Cocoon here. There are some exoskeleton, some other plugins that are installed. But normally also these ones here, they don't belong to standard Grasshopper installation. So you see that there are some plugins, but nevertheless, these toolbars start to provide some useful and nice mesh modeling tools. Um, then there are some easy or simple plugins, like for example, you might know Weaverbird. Weaverbird is actually a subdivision plugin mainly. It also allows to do some useful things, like in the extract group. You might want to concentrate, for example, in joining meshes and weld, or this is actually rerouting faces in terms of the orientation that they have. So there are some tools that are very useful, and also some transform tool, like creating holes or frames or thickness and so on inside a mesh. But the main group is the subdivision tools. So for example, if I take a mesh, a regular mesh, and then try to subdivide it, I have several algorithms, subdivision algorithms that I can use for this mesh sub-D. And I can also create some kind of tricky mesh, like these ones, for example, using simply this kind of automatic subdivision commands. Okay, so things start to be interesting with this with Weaverbird. But moreover, you have other plugins. Let me double check. Is this one, for example, which is called Mesh Plus. Mesh Plus has a huge amount of tools that allow to perform very complex operations on meshes. What's the problem with all this Rhino Grasshopper workflow, with or without plugins? The problem is that you have no control over the resulting topology. You cannot define the topology, let's say, by hand. Like, I want this topology to run like in a particular way along the body of the mesh. You cannot do this because all of these tools are somehow semi-automatic. So you can achieve interesting results, but you have no control over the real topology that we need for our workflow. Okay. Um, so we can say that the only thing that we can do here in Rhino Grasshopper is obtain some kind of rectangular mesh topology based on the UV direction, of course, but only in two horizontal vertical orientations, independently from the orientation of the mesh or the surface. Okay, so even in this case, I always have the horizontal vertical, or let's say longitudinal and cross section direction. Okay, so this is mainly the topologic potential that you have in Rhino and Grasshopper for mesh modeling. Of course, there is an alternative, but it's very time consuming. So for example, let's say that I am here in Rhino. Let's concentrate on Rhino for a while. And you see that between the mesh tools, the mesh creation tools, there is one which is called single mesh face. Okay. Single mesh face allows to create polygon by polygon a mesh. And since Rhino 6, you can create a triangle, of course, a quad, but also an anagon. So if I keep on adding vertices, I'm creating a face or a polygon with actually 6 vertices. Okay. I repeat, we don't want to work with anagons. We don't want to work with triangles. So let's concentrate on quads. Okay. So if I take a 3D face and start creating a polygon like this, I stop with the 4th vertex and then hit enter. So I have a quad. Okay. If I switch to a shaded view, I see this. Now, if I let's say orbit with a mouse and I go like watch this polygon downward, you see that it looks orange. Okay, I do recommend that you have this setting in Rhino. In shaded mode, I do recommend that you be able to distinguish between the positive normal direction of a mesh face and a negative normal direction for the mesh face. And how can you do this? You just switch to shaded mode or shaded view in perspective, for example, and then you right click on the viewport name. You go down here where it says display options. The settings window pops up, and pay attention because we are inside Rhino options. We are not inside the document properties, which means that the change that we are going to do right now is going to affect all the models or files that we are going to work from now on. Okay, so these are going to be Rhino settings. So Rhino options opens directly to view display modes shaded, because we are in a display mode shaded actually. And you see that here on the right, there are a bunch of settings. And here, at more or less half the length of this page, you see that there is one parameter which is called backface settings. Now, backface settings means how do you want to visualize the negative face of the objects. And by default, this is set to use front face settings, which means that there is no possibility to have an idea of on if you are looking at the positive or negative face of a surface. Okay, but if you switch this to single color for all back faces, you can specify a color here, whatever color you might want to use. Okay, I do recommend that you don't use a standard color. So don't use the first colors that you have here in the first part, down to red, for example. All of these that have names, don't use them, because these are directly accessible also, for example, in the layer color configuration. And you might have some difficulties in understanding if you are looking at the negative face of an object or at an object that belongs to a particular layer and therefore has this kind of visualization color. So just drop down this list and pick one of these dump colors that you have here at the bottom. Okay, I normally prefer to use orange because I want to have a clear understanding of if I'm looking at a negative face or not. And once you do this and confirm changes, whenever you create a three-dimensional object like a surface or a mesh, you will have this kind of behavior. Okay, so positive looks exactly like the visualization color of the layer it belongs, and negative will always be orange in my case. Why I do recommend that you do this? Because when you create a 3D face or single mesh face, if you pick the vertices counterclockwise, like this, you will have a face that is facing upward with its positive normal orientation. But if you work clockwise, like for example from here to here to here to here, and hit enter, you have the negative face pointing upward. Okay, so mesh orientation is absolutely fundamental when we create mesh objects. Okay, in Rhino, all of these things are mostly irrelevant. In Rhino, meshes just play a role when you create renderings. Okay, but we want to base all of our workflow on meshes, so we must clearly understand how to adjust mesh objects. We will not be creating meshes in Rhino because just think about it. Okay, if I want to create a mesh in Rhino controlling the topology, I should start creating single mesh faces with the vertex snap turned on, so I can snap to the vertices, the actual vertices of these, the existing polygons, like this, and create this like mesh by polygon by polygon. Okay, example like this. Just so that you have an idea of how long this process could be, I just created 6 polygons. These are 6 meshes, 6 separated meshes. Okay, and then we have other problems because if I, for example, select all of these 6 polygons here, and I just join them, Rhino says 6 meshes have joined into one open mesh. Now, there is another thing that can happen, because when you have separated meshes and then you just join them, you are not creating a regular mesh topology. Okay. Actually, if you go to Mesh Tools you will see that there is another command which is called weld mesh. Okay? Weld mesh, actually what it does, you see that it visualizes the interior edges like with this yellow color, okay? Then you confirm this command, and then you have weld the interior edges. What's the meaning of this? The meaning of this is that when you create a mesh with two edges and faces, like I'm going to exaggerate here, like if they were separated, like this line from this line, but they are coincident, right? Welding means that these two vertices here that lie one on top of each other are not actually blend into one single vertex. We still have two vertices over there, and also on the other side. So welding means eliminate one vertex, just keep one of the two, and then you will have one single vertex here, one single vertex here, and one single edge here, not two overlapping edges. This is the importance of welding a mesh. Okay. In Grasshopper, you can do the same. There is, let me go inside the mesh toolbar, and in utility, there is the weld mesh here. You see, there is the same command. And there is also Weaverbird, as we saw. There is a command that automatically join meshes and welds them. Okay. Now, you might think, okay, so it's just a matter of time. I just waste time modeling the polygons one by one, and then I join them and weld them. I can do this both in Rhino and Grasshopper. Yes, but it's not as efficient and as in a polygon modeling tool like Blender, for example. Okay, so it's very easy that when you have a complex topology, these commands simply don't work. Okay, so don't rely on them. That's why we are going to exit Rhino and work with Blender to create our base meshes. Okay, and the other problems that we have here in Rhino is that if I still add polygons to this, for example, like this and like this polygon and this polygon here and this one, so I am creating two rows of polygons, right? Like this. If I do this, and I also join all of these, Control J is like joining, and then I weld everything. You see only the interior edges get bright yellow, and then I enter, and then everything here it's welded together. Okay. So if I have this, what's the U orientation and the V orientation of this mesh? Okay, so Rhino doesn't care about this at this moment. Okay, Rhino only cares about the mesh orientation when you want to perform some kind of rendering. And so if you go here on this object and you want to apply some texture mapping and you want to apply some kind of unwrap, or you want to create some, and you want to use the custom mapping and the UV editor, in that case, you have access to the UV properties of this mesh. But is not, Rhino is not based on this. And as it is not based on this, we have no modeling possibilities in Rhino to create complex meshes. Okay. So what we're going to do, we're going to leave Rhino aside for oh, also there is another thing that I wanted to point out. So let's say that we, you know that Grasshopper is the parametric phase of Rhino. So all of these clicking for creating a quad, for example, in Grasshopper can be, let's say, created with a parametric and semi-automatic process. Okay, and of course this is true. But if you create a construct mesh command, which is actually the command that allows to construct a mesh from its vertices and faces, you will quickly understand why this is not healthy. Let's say so. So how this construct mesh works? It works like having a list of vertices with their own coordinates, as you can see. And faces is actually not a polygon, it's the connection scheme for these vertices. So you see that if you have these 4 vertices here, if you want to create one single quad polygon, Q, you must connect vertex 0 to vertex 1 to vertex 2 to vertex 3 in this order. So faces is not the polygon, is a connection scheme. So for example, let's say that instead of having this kind of situation here that I'm going to copy, if I create a panel with this thing and plug it into faces, you see that I get the same result, okay? So what if I go inside this panel and say I want a triangle, um, parentheses, connecting 0 to 1 to 3, okay? So I no longer want a quad. I just want this triangle. So if I do this, I have this mesh actually. And this mesh is not using actually this vertex, okay? So if you want to control the creation of a mesh in Grasshopper, you must do this kind of operations here. I'm going back to a quad, okay, because I don't want to miss vertices. So what happens, for example, this is a simple quad, right? What happens if I want to create a stripe, a strip of polygons, okay? Let's say that I start to provide Grasshopper with a collection of points, like set multiple points and start picking always counterclockwise, remember? So 1, 2, 3, and 4. And now what happens when I have, for example, vertex 5 and 6? Because I don't need other vertices. I don't need another vertex here and another one here. I just need this cobble here that will be connected via the face connection scheme to this vertex and this one. And then I eventually need this one and 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 this one. Okay, so this is going to be the two lines of points that I want to use for creating the mesh. And I plug them here. Faces only contain one quad, which is 0, 1, 2, 3. If you want, you can also use, in order for having a clearer perception of what's happening, there is a command which is called point list. We just give a size to this text, and you can see the number of the points, 0, 1, 2, 3. Then, in order to create a second quad, I must connect 2, 4, 5, and 3, right? So if I want to create this mesh, I should create a panel with this first quad, and then another quad that connects 2 with 4, with 5, with 3, okay? Like this. And then I must deactivate the multi-line data in order to have two separated or two list elements in these connection schemes and plug this into faces. So I start having a mesh with 2 faces and 12 vertices, and so on. So if I want to create a mesh with a topological control in Grasshopper, I need to do this kind of thing. Like, for example, no, sorry, for 6, and then 7, and then 5. And we have 3 polygons. So can you see how time-consuming is this process? And also, we are also talking about a simple line of polygons. There is nothing rocket science here. We are not creating some kind of complex spherical mesh, for example. It's just a line of polygons. And we must pass through this process. So I would not recommend you do this, okay? So let's see what's the difference when we start working with a polygonal modeler like Blender. So I'm going to run Blender right now. And what we're going to do at first is understanding how to create a controlled mesh topology in Blender. Okay. If you have recently installed Blender, eventually you might already have a cube inside your scene, and you might also already have a camera somewhere like this, and you might also have some kind of sunlight like this. Okay. Now we don't need any of this. Okay, so you can in Blender there are several things that are done via keyboard shortcuts. So it's very common to use the keyboard to run commands. In this case, I'm going to click on the A key, so I select everything, and then X key to delete everything. Okay, so I don't need any of the objects that we already have in our standard model. So let's have a completely blank canvas in this case. What we're going to do right now is start creating the same strip of polygons that we were creating in Rhino, just to understand how easy it is to do this in Blender. Okay, so first of all, I want an initial quad. Okay, so if I want to add something in Blender, I can use the menu that is here, like Add, and you can see that all the things that you can add in your scene directly. Or if you are here inside your working area, you can press the Shift A keyboard shortcut, which is basically the Add menu. So however you feel comfortable, right? So Shift A Mesh, and we are going to add a simple plane. Okay, so this is the first quad. Now, in Blender, you can work in several different environments. Okay, this environment that we are working in by default is the object mode. Okay, so what I'm seeing right now is the object in general with its properties, like, I don't know, the shape and the orientation and the color. So these are all object properties. Okay, and this is a mesh plane. Okay, if you want to edit the mesh, you cannot do it at the object level. You must switch to the edit mode. In edit mode, you work inside the object. You are not changing some object properties. You are editing the object topology. Okay, how do we switch to edit mode? Well, there are mainly two things that you can do. You can go where it says object mode and pick the edit mode menu here. Or if you are in object mode, you can press the tab button in your keyboard. It has the same effect. So actually, tab is a switch that allows to switch back and forth between object mode and edit mode. So double check that we have created a plane and we have switched to edit mode. In edit mode, we have access to the mesh topology. Once we are in edit mode, we can select the mesh object by selecting its vertices, as you can see here on the top, edges, or faces. So if I remain with the vertex select tool, you see that I see these 4 orange dots here at the corner. If I click on one of them, I can move it around, for example. Move in Blender is G. So actually I'm moving this polygon. Of course, by moving this polygon, I am changing the shape of the object, okay? But I'm working at the topological level. So I am editing the mesh elements, like vertices, edges, and faces, okay? Why is this better than working with Rhino? Because if I have this initial quad, I can switch to, for example, edge select. You see that I no longer see the 4 dots at the corner, because now when I click here, I can select one edge. You see that it turns white, right? So once I select one of these edges, I can, via the G key, I can move the whole edge, as you can see, okay? But I don't want to move this edge. What I want to do is extrude this edge. So if I hit the E key, I am creating another polygon. And this other polygon is automatically weld to the previous one. And I can select this edge here and extrude it, and extrude it, extrude it, and I've created a stripe of polygons in a very easy way. Okay. So it becomes very simple to create this kind of objects in Blender. Of course, because Blender was made for creating this kind of geometry. It's made up for working with meshes. Okay. If I switch back to object mode, like hitting tab button or like switching to object mode here, Now I'm back to the object mode. And I no longer have access to the topology of this mesh. I just see the object and eventually can apply material or whatever I want to this thing. I can do some a global transformation like G moving the whole object, R rotating the whole object, S scaling the whole object. You know. But if I go back into edit mode, I can, for example, select one topological element and move it along, rotate it along, and scale it along. So topological editing allows us to define the mesh properties according to its original elements. Okay. When you work in Blender, you see that the mesh doesn't have any information about the orientation. Actually, you don't understand what is the positive or negative phase of this mesh. And it's important to us to understand it because of the process that we are going to undertake later. So I want to see what's the positive or negative phase of this object. This is a visualization setting. So if you go here on the top right corner of this viewport, you will find this thing here. It says show overlays, but this is not what we are interested into. We must click on this arrow here, and overlays are actually viewport adjustments. So this is the meaning of overlays. And my overlay, the overlay that I'm interested into is the face orientation, as you can see here, this one. So if I click on this, now we see blue for the positive phase and red for negative phases. Okay, this is something that you might want to activate only in particular occasions because it's here it's a little bit different from Rhino. It's not always a pleasure to have this blue-red visualization for the mesh objects. So normally I do recommend that you activate this option only when you need to clearly understand what's the orientation of your mesh. Okay. So the real power of Blender is not only the mesh object creation, okay, where you have some very interesting tools, but it's the edit mode for us. So we are going to work in edit mode quite a lot. And what we're interested into is to adjust the mesh topology for the workflow that we're going to create. So in edit mode, I want to go back, for example, to one single polygon, one single initial quad. Okay. So what I'm going to do, I can, for example, switch to vertex selection. And I can select all the vertices, all these vertices here with a selection window. Select all of them and X delete these vertices. If I delete these vertices, the edges that end in those vertices can no longer exist, and then the faces are missing the boundary, and so also the faces disappear. All of them but the first one, because its 4 vertices are still here. Okay? So let's have a quick look to what we can do, topologically speaking, in Blender in order to create complex objects. Okay? Then we will eventually, let's say, start creating an interesting mesh object in Grasshopper, import it in Blender, adjust the topology, prepare the fiber structure, and then go back in Grasshopper and create the fibers. Okay, so this is going to be finally our workflow. It's going to be quite architectural, but it applies to every kind of objects. So let's say we have this initial quad here. Okay, it's no longer the initial quad, which was lying here at the bottom, but it's like floating a little, but it doesn't matter. Okay, so once you are here in the Blender interface, if you hit the T button, you see that there is a toolbar on the left that pops up. Right, this is the T key in your keyboard. These are actually the tools that you can use in a particular environment. Remember that we are in edit mode, okay? In edit mode, one thing that we can do, for example, besides extruding, which is this command here, we can also, for example, inset faces. So if I go to face selection and I select this face here and I hit the inset faces button, now if I move the mouse inside this, I prefer to work with the keyboard. Sorry for that. Inset is actually E. Okay, so if I E, you see that this is the actual inset that I am creating. Okay, so inset is taking the actual edges, is creating some kind of offset toward the inside of the face. So with the E key, you can create this inset face behavior. And we can also repeat this. For example, if I take this face here, this face here, this face here, and this one, and I hit I right now, you see that I'm creating an inset for the whole boundary of this mesh. Sorry, it's the I, not E. I is for inset, okay? So each time I select a face, like these two, for example, I can inset them and create some kind of topological editing of this. And of course, once I have these are independent faces. Well, they are connected, but they are one single face. So if I hit the G button in order to move them, I can create some kind of, let's say, geometric variation for this object. Okay. I can also create some displacement for this, like this. Okay. So there is not only extrusions. We also have a complex set of tools inside Blender. For example, let's say that I want inside this object here, this base quad, I want to create some kind of let's say, I don't know, like panel here. So I can once again inset this once again, and I can, for example, G this, like moving this vertically, okay, and I create this kind of inset here with some height, okay. Now, when we start working with meshes like this, we start to create some very complex topology. Okay. Remember that we are interested in creating some topology based on the UV direction. So let's call them horizontal vertical direction, but it's not probably correct. But just remember that we are interested in having a clear orientation for our mesh. Now, for example, this is just to explore the inset command. Okay. Another thing that we can do, for example, not that we have this kind of polygons already present here, we can also use other commands. For example, bevel. Bevel is actually capable of creating like a chamfer. I think this is the proper word in Rhino. Also, you have the chamfer command. You have to select the edges in this case, because you can bevel edges, of course. And so if we start beveling these edges, you see that you have this kind of additional polygons coming out from the elimination of the original edge. Okay? So we are chamfering these edges. Okay? Probably the more interesting tool is this one, which is called loop cut. The loop cut adds some cut along the U and V directions. Okay, so for example, you see that if I hover with the mouse in this area of the mesh, you see that this yellow line appears and runs through the mesh along one topological direction. If I move with the mouse along this other line here, the same yellow line appears in the other topological direction. This is actually like a cutter. So if I click with the mouse here right now, you see that I have created a separation line, this orange line here, which is a line of edges. So I no longer have one single quad here at the center. I have two quads, 1 and 2. And if I hover with the mouse here, you see that now the next loop cut is actually splitting all these stripe of polygon into halves. So if I do this and this, I now have a more complex topology in this direction. And I can do also the same thing like here, here, and here, and go back to the selection tool. So I have created a higher resolution for the same object. And I can also, for example, go here and select faces, select these. With Shift, I am selecting more faces. And I can inset them to create this change. And I create something like this. So I'm adjusting the topology in order to perform some kind of editing, of shape editing for this object. Now, this is starting to be quite a complex mesh, okay? And what I want to do, I want to concentrate on what are the internal orientations for this object, because I need them in order to keep the mesh topology clean and usable for the next phase. There is a way when you are in edit mode and mesh and face select tool, and you have this kind of complex object. If you click on one quad, you see that you only select one face. Okay. Let's say I want to select the whole U or V stripe of polygons at once. In that case, I can go with the mouse close to the cross edge, referring to the direction that I want to consider, which is this one. The cross edge is this one or this one, whichever you want to consider. If you go here with the mouse and then you alt click with the mouse, then you are selecting the whole stripe of polygon in that direction. Now, what we need is to create defined loops in the U and V directions. So this is a, let's say, a V loop. If I Shift Alt click on this edge, I select another loop in this direction. What happens if I Alt click on this edge here? So Alt click here. You see that there is this stripe here that flows, passes here around this corner, and goes here. And this other one, Shift Alt click, is doing this. What happens to these two polygons? They don't belong to this loop here, and they don't belong to this loop here. So they are basically isolated. They don't belong to any loop of that we have selected. Also, if I Alt click on this edge here, you see that I get a cross loop. And this is actually overlapping with these two loops here. So this polygon and this polygon belong at the same time to these V loops and to this U loop here. And also this selection is leaving this polygon here outside from the selection. So another polygon that stays here like disconnected from the UV theory of polygons that we have. Okay, so there are lots of problems in this mesh. Problems that we cannot leave like unsolved, like in this case. So I'm going to show you, in order to have this situation a little more clearer, I'm going to show you what a regular topology looks like. Okay, so I'm still in edit mode. I'm not creating a different object. I'm creating a different part inside the same object, right? So I Shift A and add a plane. Now this plane belongs to the same object. If I go back to the object mode, you see that there is not two planes. There is just one plane. And if I select this, also the other one gets selected. And if I select the other, also the first one gets selected. Okay. So this plane was added in edit mode. So it's a separate part of the same object. Okay. So if I go back in edit mode, I have this plane, which is independent from the first one, but it belongs to the same object. What I'm going to do, I'm going to GX, which means move along the x-axis, this quad, like this. So I have it now in a different area with respect to the first plane object. And what I'm going to do with this is the following. I'm going to inset this face, like this. And I'm going to extrude it vertically, like this. And I'm going to select the face, like this face here, X, delete just the face, not the vertices, just the face. So I keep the 4 vertices, the 4 edges, and I don't make the vertical faces disappear. Okay? If I had eliminated the vertices, also this edge could not exist because it would miss the upper vertex, and also this one, and this one. So I will also be deleting the 4 vertical faces. And then what I'm going to do, I'm going to select edges, select this edge plus this plus this plus this. And what I'm going to do, I'm going to do a, let's say, an operation that it might look like counterintuitive, but I'm going to extrude this. And while extruding, I'm going to hit scale S. So I'm going to create the same topology that we have at the base of this column, let's say so, by extruding and scaling at the same time the upper edges. Okay. Now, this is a regular topology in terms of UV direction, and I'm going to show you why. If I move back to the face selection, like this, if I alt-click on this edge here, I select this loop. This loop runs from the base to the top of the column along this side of the column. If I Shift-Alt-click on this edge here, I select this other loop here, which is independent from the other one. And if I Shift-Alt-click this and Shift-Alt-click this, I have 4 separate P loops. Okay. At the same time, I can also Alt-click on this edge here, and I select the bottom loop. I can also Shift-Alt-click on this vertical edge, and I get this vertical faces horizontal loop. And then I can Shift-Alt-click on this diagonal edge and get the upper horizontal loop. So we have 4 vertical loops and 3 horizontal loops. This topology is perfect for what we want to obtain. What we want to obtain, just so to have an idea of the result that we are looking for, is going to be this kind of thing. This kind of thing. Okay. We want to understand how to tweak the mesh topology in order to have it flowing in a very regular way along a very complex object like this one. Okay, so that's why we are concentrating on these things. The interesting thing of this regular topology is that if you create it like in a very low poly fashion, like in this case, whatever type of subdivision you apply to this object, it will maintain the actual topological regularity. Okay, so for example, let's get rid of this because we already know that this is not going to work because it has this kind of UV problems. So what I'm going to do, I'm going to switch to vertex selection and then select these vertices here. You see that in Blender, normally when you don't see things, you cannot select them. So if I select all these things here, you see that some vertices get not selected because they are hidden normally. So if you want to avoid this, I do recommend that you switch to wireframe visualization. So you simply hit the Z button and select wireframe. Now you can see through faces. So if I do this, I am selecting all the vertices. See? And once they are all selected, I hit X button and delete all the vertices in order to get rid of that object there. Okay? So we only have our square column here. And we are going back to object mode. Okay? So what I want this object to have a more complex topology, because I don't want this kind of stupid 90-degree connection along these edges. Okay, I want some geometry like a little more organic, like something like this. Okay, so in order to do this, I have two options. I can work with some kind of mesh relaxation, which is one option. And the other thing is I can apply some subdivision algorithm. Okay. Whatever you might want to do, these kind of things in Blender are called modifiers. Okay. So when you see this gear here, this range, you go here, and then you can add modifier. There is a whole bunch of modifiers that you can apply to objects. Of course, it depends on the type of object and on the type of task that you must do. But in our case, it's going to be very simple. There are two main possibilities. The first one is using a subdivision surface. Okay, so in object mode, we can select this object and apply a modifier which is called subdivision surface. Now, the subdivision surface creates this kind of deformation. Okay. Why it creates this kind of deformation? Because it is based on the Catmull-Clark algorithm. Now, I don't know if you know how the Catmull-Clark algorithm works, but it's not only subdividing the mesh, creating more polygons and increasing its resolution, it is also smoothing the edges of the mesh, or the original mesh polygons. So that's why you see that from a square, we now have an octagon, okay? And therefore, this thing is starting to look more cylindrical than a box, okay? When you apply a modifier that increases the resolution, Blender tries to keep things simple by visualizing only the necessary polygons in order to don't stress the graphic card, okay? But if you take a look here at the modifier settings, you have this optimal display. If you deactivate this, you are going to see all the actual polygons inside this object, okay? Of course, this is just one Catmull-Clark subdivision step, okay? But you can also go here in the subdivisions control. We are not interested in the render amount of subdivision because we are not going to deal with rendering, okay? We are only willing to control the viewport subdivision, meaning the actual model subdivision. So viewport, you see, is set to 1. So this is just one application of the Catmull-Clark subdivision algorithm. But if I increase this, for example, to 2, now I have a more complex object with more polygons. Or 3, for example. We are getting this kind of wormhole object here. Okay. Now let's keep it simple. Let's avoid stressing the computer too much, because when things work with one subdivision, they will work with 10 subdivisions. The only difference is that you are going to wait for hours. Okay. So let's keep it simple. And what I'm going to do, I am going to apply this modifier. Okay. So this means that until you apply the modifier, you always have access to the original mesh topology. Actually, if I don't apply the modifier, okay, and I switch to edit mode again, you see that I have control over the original topology, not the Catmull-Clark or subdivided topology, right? So these modifiers here are actually, they behave some like of visual editing or visual change of things, but you still have access to their nature. Okay, so in this case, this kind of square-ish column. Unless you want the modifier to be visible in edit mode. If you want the modifier to be visible in edit mode, you have to click on this button here uh, as regard the modifier settings. And so you see that when you apply this, when you activate this option, even in edit mode, you just see the modified object. Okay, but you have access to the original topology. So despite the fact that in object mode you have this amount of polygons, when you switch to edit mode, you only have access to the original vertices. Okay, this is because the modifier has not been applied. So you have the original topology, but the modifier shape. Okay. So if I go in object mode and decide to apply the modifier, the object stays the same. But if I go to edit mode now, I have all the topology of the modified object. Okay. So we are in edit mode of a more complex column. Okay. I'm going to switch to face selection. And what I'm going to do, I'm going to click, alt click here. You see we have a vertical loop. And then we have shift alt click, another vertical loop, another vertical loop. You see that by applying this modifier, we have not changed the topological condition. We have clear vertical stripes of polygon, as well as clear horizontal stripes of polygons, separated, and they cover all the object. Okay, so this is an extremely regular topology. Okay, and what I'm going to do right now is another thing. I'm going to undo a bunch of things. Or no, I'm not going to undo anything. I want to keep this like it is. Let's go back to object mode. And I'm going to add another object, a different object. I'm going to shift A mesh plane. Okay, so let's work with another thing. This is not a part of this object. These are two separate objects. So this might be, for example, here you see that on the right you have this project browser, or like the scene collection list. And you see that now we have this plane, which is the original column that we created. And now we have plane 001, which is the new plane. Okay, so I can rename this plane here into, I don't know, column. And this is going to be some kind of fancy organic shape, something like this. So what I'm going to do right now is go into edit mode for this fancy organic shape. And what I want to do something like the thing that I did here, okay, but a little bit different. Oh, by the way, let's also hide this column so we don't have it around when creating this model. Okay, so I just have one polygon. Okay, I need to create some kind of a structure like the column that we have created a while ago. So what I'm going to do, I'm going to do this this thing. Like we did before, I'm going to I inset this, E extrude it, and X get rid of the faces, so the upper face, and switch to edge selection and select 1, 2, 3, 4 edges, and then extrude them by scaling them with S. E extrude, S scale, so I give them this kind of width on top. So everything is identical to the previous step, right? But now what I want to do, I want to select everything. So the whole set of objects, of elements that we have here. And I want to copy this object to the right along the x-axis. Now copy in Blender is Shift D. Okay, D like, I don't know, data or dinosaur. So Shift D, we are creating a copy of the object. I want this copy to move along the x-axis. And so I have these two things here. They are identical, They are two parts of the same object because we are in edit mode. Okay? So now we have two separated columns, but both of them have a very regular topology because we have controlled it and created it like exactly like the previous column. And we already saw what are the effects, for example, for the previous column. So let's see what happens when you have a more complex situation. Okay? So for example, if I want to join these two parts into one single piece, what I can do is select the edges, like select this edge here, plus shift this edge here. And I want to create a polygon, like a face between these two edges. And it's simply F. F key creates this face. I do the same here at the bottom, F key. And so I have this object here. Now, let's see what happens in terms of loops, okay? So alt click, for example, like mesh face selection, alt click here, we have this loop. Alt click here, we have the other loop. Alt click, the other loop. What happens when I click here? Alt click here generates this loop here, this ring. And when I keep on alt clicking on the base edges, you see that I have all separated vertical loops. The only difference is that this interior loop here is closed. Okay, so it's circling, it's running from one part to the other part and go back. But they are still separated. Now, what happens with the horizontal loops? Because if I alt click on this or this, everything works fine, right? The problem is what happens when I alt click on this edge here. We have this loop here, and we have this loop here. This is not correct, because with horizontal loop, we are not capable of considering the inner faces that we have created. Okay, so this is a problem, and we need to solve this problem because we don't want any polygon to stay out of these loops here. This is going to, if we leave things like this is going to affect the fibers creation. So what I need to do here is create a different topology. So I'm selecting these two faces here and X delete faces. Okay. And what I'm going to do, instead of creating an additional face here, I'm just going to weld this line here with this line here, as well as this line here with this line here. Welding can be done by switching to vertex selection and select the pair of vertices that you want to weld. If you select these two vertices and click on, on the M button, the M key, you have the merge command. And I want to merge these two vertices here at center, so in the midpoint between them. And so I get this. And then I select these two here, M at center, these M at center, these M at center. So we no longer have any duplicated points because we merged. And as we merged both this vertex here and this vertex here, we only have one edge here in the mid connection. Let's go back to face selection. Let's alt click on this. Now you see we have this loop here, and we have this loop here, this one, and then this one, and this one. Vertically, we have this, and also on the other side, we have this regular loop. Now, we are covering the whole object with the horizontal and vertical loops, but keep in mind that the horizontal loops here on top and at the bottom, they are two separated loops, actually. Okay, so it's not just one single loop at the bottom. And this means that when we will have our geometry running through the object, it will run in circles around one column and in circle around the other column. Okay. So let's see what happens if we go into object mode again and apply a subdivision surface modifier. Okay, with a couple of steps, we start to get this kind of interesting topology. We can also see this in solid mode, so we have a clearer understanding of what kind of object we are creating. Okay, and it's also important to understand what are the positive and negative orientations. So from now on and then, you might want to activate the face orientation. Okay. So you see the positive is blue and negative is red. So everything is looking perfectly. We don't have any flipped normal along this mesh. When you see a let's say wide surface like with this red color, and suddenly you see some blue square or blue area, small areas, in that case it means that you have some orientation problem for your mesh. This is an object that we will be using eventually in order to understand how loops work with it. Let's say that, well, let's leave it like fancy organic shape. And what I'm going to create next, I'm going to turn off also the preview of this. I'm going to create another base object, which is going to be another plane, of course, another plane. But this time we are going to do something different. Okay, so we are going to create this original plane. We are going to apply, well, let's go into Z wireframe. We are going to apply a subdivision modifier like this. But this time we are not interested in this smoothing effect from the Catmull-Clark. We are only interested in the simple subdivision. If we turn off optimal display, we see what simple means. Each polygon is simply split into 4 polygons, but without smoothing anything. It's just the amount of polygon is going to increase as I increase the viewport value. Okay, so we need something like this, 3 subdivisions. Okay. Eventually, this 3 subdivision is going to create a very complex object, and maybe at this point it's not convenient to create a mesh object with a high level of complexity. So eventually, look, let's do something. Let's delete this modifier. So remove modifier here, and let's go directly in edit mode, and let's subdivide this by hand. Okay. So in order to subdivide this by hand, I want to use the loop cut tool, but not by hitting this button here. So I'm still in selection mode. Loop cut can also be applied by clicking Control R. Control R has the same meaning of loop cut. And by hitting Control R, you not only are able of splitting one polygon in one direction, you can also use the mouse wheel. If I rotate the wheel upward, I increase the amount of loops that I can create. And if I rotate it downward, I decrease the amount of loops. Now what I need is this. I need 4 cuts. Okay, 4 cuts in this direction. So I click with the mouse right now, and I click once again to confirm the position. And I repeat on the other orientation, Control R, scroll the wheel, so I have 4 loops cut, and then I click once, and if I don't click twice, I can move these loop cuts around, okay? But I want them to be exactly in the center of this polygon, so I just hit the mouse button immediately once again. So I have created this kind of subdivision for this original polygon. Once we have this, what we are going to do is create quite a complex object, actually. I'm going to select everything by hitting A button. And this time, I'm going to duplicate this by Shift D in the Z direction, like vertically, like this, at a certain height. I don't care actually. And then what we are going to do, we are going to switch to face selection. We are going to take this face here and this face here and hit X and delete faces. And then on the upper surface, I'm going to select this one and the opposite one, and I'm going to delete them as well. So we have this kind of situation here. And what I want to do, I want to connect this hole with this hole, and this hole here at the bottom with this hole here on top. So in order to do this, I'm going to switch to edge selection, and I'm going to select these 4 edges here, shift these 4 edges here. Now in Blender, we can connect closed, or we can connect edge loops with a set of faces. So if we do this, we can right click with the mouse button, and this bridge edge loops appears. Bridge edge loops create exactly this connection here. If you don't, normally in Blender interface, many things depends on how you adjust the input device settings. So like, for example, the mouse in this case. But if you prefer to work with menus, in edge menus, you will find the bridge edge loops. Okay? And we are going to do the same thing on the other side. So let's select these edges here, and also these edges here, and edge, bridge edge loops. And so we have this kind of object. Let's go back to object mode. Okay. What happens if I select this thing here and apply a subdivision surface? You see, we are creating this kind of very interesting surfaces. They are, let's say, I think that also, I don't remember if it was Tanawando that recently created some structure using this principle. It's like in a hotel, maybe, I don't remember exactly. But anyway, we are creating a very complex object right here. Okay? We can also take a look at this in the solid visualization. So you see that the main property of this thing is that if you, let's say, are located on this face of this surface, you can move along the surface, and suddenly you are on the other side, but there is no possibility for you to stay on the inside of this surface. Okay? So this kind of connection creates two separated environments defined by the same membrane. So it's very interesting, like in creating this kind of object. Now you might see, for example, that we have a problem. You see that now at the bottom we have a very a smooth connection, okay? While here on top we have a very sharp connection. Why? Let's take a look at what happens in this case to the face orientations. Because remember that I created, let's run through this process. I created a horizontal plane, and despite the subdivisions and everything, this plane had the positive normal like this, okay? And then I duplicated this like vertically, and then I had another horizontal plane at this height with its positive normal like this, okay? So when I connect like with these diagonal faces, these to these, okay? This polygon here has its positive normal oriented towards us, okay? So we have positive face, and here it is connecting to the negative face because it connects to the on the bottom of this upper floor, say so. And so this is creating this kind of connection error or behavior. So if we go into the overlays and activate face orientation, you see that we have a problem here because we have blue on this part of the floor, blue on this diagonal connection, they connect with a red. Okay, and this means that we have an orientation problem. Okay, so when we have this, you can go, for example, to the I think it was in the edit mode, but just to avoid going back and forth, yes, I think it's in edit mode. So if I select all the faces of this object, and I go here in mesh normal, and I hit recalculate outside, Shift M. If I do this, now it already adjusted the mesh so that there is a smooth continuity between inner faces and outer faces, as you can see. So if we go back to object mode, you see that there is no longer this red-blue problem. And as the connection happens in a smooth way, then there is also the possibility to have this kind of smooth connection instead of sharp creases. Okay. So this is going to be another object that we are going to use for our, let's say, mesh topology creation. Okay, I'm just going to decrease the amount of subdivision to the minimum because we are going to need this, and then eventually next we are going to be able to work with a high resolution topology. Remember that once you define the topology correctly at a very low resolution level, then you can increase the resolution and the UV regularity will be kept. So it's not worth increasing the quality of this mesh because you will only have to deal with hundreds of thousands of polygons instead of the minimum amount possible that allow a clearer understanding of the mesh topology. Okay. And eventually what we are going to do, for example, in edit mode, eventually we are going to actually work with the on cage option. Oh, there is a question. Show the comment again. I missed which comment, Sagar? Oh, the normals. Yeah. Okay. So yes, let me reactivate the shaded. Sorry, the shaded. So I'm going back. Yeah, this one. Okay. So from object mode, we have this problem. From object mode, we switch to edit mode. We select all the faces. We go into mesh, normals, and it's called recalculate outside or recalculate inside, whatever you please. The important thing is to have a smooth continuity between outside and inside. Okay? And once you have done this, you can go back to object mode and you will see that everything is working properly. Well, at least as for the orientation of this mesh, we no longer have any problem, any orientation problem. We still have topological problems, but we will deal with them later today. So I deactivated the face orientation. I don't want to see the colors anymore, and I'm going to decrease the amount of subdivisions for this mesh, and I'm also going to activate the on cage for this subdivision surface modifier, because when I go to edit mode right now, I will have the original mesh topology, okay, low resolution, but flowing according to the modifier. Okay, if I don't do this, I will have the original topology like if there was no modifier applied. You see that this line goes straight, while the actual mesh, due to the modifier, is actually bending like this because it has been smoothened up by the subdivision modifier. Also, these corners here are rounded because of the smoothing algorithm, which is the pattern plug. But if I hit this, I will have the same low resolution topology flowing according to the modifier shape. Okay, so if I select the vertices, I see that the vertices follow the actual deformed topology. This is going to help us as well. And now what we are going to do, we are going for a break, something like, I don't know, 20 to 25 minutes normally, in order also to eat something. Sorry, there was a quite a loud noise and also a helicopter right now. But anyway, what we are going to do next after the break, we are going to take care of these mesh topologies. Uh, yes, of course, you get recording of this later. Um, we are going to adjust the topology in order to create regular mesh loops for all of these objects actually. So remember that we have a um, simple column, which is this one. We have this double column, let's call it so, and then we have this complex object here um, that we can also scale up a little, so it's a little more balanced with the other ones. So we are going to take care of these topologies in order to create a regular mesh topology for the fiber structure creation. Okay, and this is going to be the more complex scenario, of course, as you can imagine. Um, so let's go for this break, and I'm not going to close the meeting. I'm just going to turn off the microphone and stop sharing the screen. Okay, so I will call you in a while. Okay, so see you in a while, guys. Hello, guys. You ready? Hello, hello. Hello, guys.
I'm back.
Okay, nice, perfect. And Atish también. Okay, perfect. Well, okay, so let's resume from here. And now I want to clearly understand what are the problematic situations that we want to avoid, because we already saw that we must take into account this loops thing. Okay. Um, so what I want you to understand is this. Let me create a. Oh, this is the. Let's call it continuous surface. Okay. So let's get rid of this for a while. Let's add another mesh plane. And what I want you to understand is what happens in terms of loops when we have a problematic situation. So in edit mode, if I select this right edge and extrude it along X, extrude it again along X. So we now have 3 polygons, okay? Then extrude it along X and rotate it a little, like this. And then extrude it again, and extrude it again. And then I select this edge here and extrude it this way. Now we are creating a Y connection, okay? What happens when I switch to face selection and I alt click on this cross edge? You see that only one part of this mesh gets selected because the loop only runs in one direction. So this bifurcation that we have here is not taken into account by this loop. We must avoid these kind of things, okay? So how can we, for example, make this situation a little more regular, okay? So that we have 2 loops that run in this direction and absorb the whole mesh. But in this case, it's not that complicated. We might, for example, let me select all of these things here. Let's get rid of these faces. Let's see how we can adjust things by, let's say, tweaking a little this situation. And I'm going to simply duplicate this set of 3 polygons. So Shift D, and I move it here and rotate it. So I need to have this, and Shift D, move it here, rotate it as well, and have it here. And of course, these 2 vertices here must be coincident. So what I'm going to do, I'm going into vertex selection, select these 2, merge them with M at center. So I need to fill this gap here, okay? Now, remember that we always must work with quads. So I cannot simply select these vertices here, all of them, and select F faces and create this one. Because this is a pentagon, it's not a quad. So if I try to select the loop, you see Alt click on this edge here, you see that the loop stops when it finds the pentagon. Okay, because the pentagon is not UV orientation. Okay, so I cannot create a single face here. I need to work in order to get 2 connections. Both they must be quad. And the only thing that I can do, see, you have 1 vertex here, 1 vertex here, 1 vertex here, 3, and then 1, 2, and 3. So the easiest thing that we can do is actually create a loop cut. So Control R here in this position. Because now, if you see, we have 1, 2, 3, and 4 vertices. So this is a quad. And 1, 2, 3, 4 vertices, and this is a quad as well. So if I select these 4 vertices and create a face, and I select these 4 vertices and create another face, now we have a bifurcation, but we also have Alt-click here, we have 1 loop, and Alt-click here, another loop. And both of them cover, they both together cover the whole mesh that we have created. So this kind of intervention that we did here is the type of work that we will have to do on our complex objects in order to regularize the mesh topology and have it split into loops. Okay. So this kind of topological adjustment is what we are looking for, and this is something that absolutely we cannot do this in Rhino or Grasshopper, because as you can see, we need a very precise control over the topology of our meshes. So we have these 3 objects here. Now, the first one is very simple. So if I concentrate on the column, this is very simple. It actually it is already a good topology. We already saw this. If I Alt right click on these edges, you see that I get separated loop for each click, and all of them cover the tower, the column. Also the horizontal loops. Okay, So we don't need to do anything for this column. This is a perfect topology. But if we take a look at the fancy organic shapes, which were these two columns, basically, here we have some problems. Because we saw that the horizontal loops are separated. There is not one single loop running all around this object, which is what I want. Okay, so how do I create a more regular topology for this object in order to avoid that kind of situation?